Crickets are insects belonging to the order Orthoptera. Crickets are found in diverse habitats worldwide. The ubiquitous presence of crickets makes their chirping a common background sound in many environments. Crickets play a significant role in various ecosystems. The sound production mechanism of crickets is rooted in their unique anatomical structures. Male crickets possess specialized structures on their wings, specifically designed for sound creation. The file and scraper on the cricket's wings are essential for generating sound through friction. The process of rubbing the scraper against the file generates vibrations, which are amplified to produce the cricket's chirp. The frequency and amplitude of the vibrations determine the pitch and loudness of the cricket's song. Variations in wing structure and rubbing techniques allow different cricket species to produce unique songs. Insect wings feature a ridged area known as the file. The opposing wing has a hardened structure referred to as the scraper. The file and scraper mechanism is essential for stridulation. Stridulation is the sound-producing mechanism in certain insects. Stridulation is defined as the act of producing sound by rubbing certain body parts together. The file and scraper mechanism is a common method of stridulation among insects. Rubbing the file and scraper together generates vibrations. These vibrations produce the characteristic chirping sound associated with crickets. The frequency and intensity of the chirp can vary depending on the insect species and environmental conditions. Stridulation serves various purposes, including attracting mates and establishing territory. Sound waves are generated by the rapid rubbing of wings. The frequency of sound waves determines the pitch of the sound. The amplitude of sound waves determines the loudness of the sound. Higher frequency waves correspond to a higher pitch. Greater amplitude waves correspond to a louder sound. The combination of frequency and amplitude defines the characteristics of the chirp. Crickets possess tympanal organs, functioning as ears, located on their front legs. These tympanal organs are specifically designed to detect vibrations in the surrounding environment. The primary function of the tympanal organs is to perceive the chirps produced by other crickets. Detection of chirps facilitates communication between crickets, enabling social interactions. The ability to hear chirps is crucial for crickets in finding mates and avoiding predators. The location of ears on the legs is a unique adaptation that enhances survival and reproductive success. Sound propagates through the air as pressure waves. The intensity of sound diminishes with increasing distance from the source. Vegetation can affect sound transmission by absorbing and scattering sound waves. Humidity influences sound transmission due to water molecules interacting with sound waves. Environmental factors collectively impact the clarity and range of sound. Temperature significantly influences the chirping rate of crickets. As temperature increases, crickets tend to chirp at a faster rate. Dolbear's law describes the relationship between temperature and cricket chirping rate. The chirping rate can be used to estimate the ambient temperature. This correlation is observed across various cricket species. Environmental factors beyond temperature may also affect chirping rates. Dolbear's law uses cricket chirping rates to estimate ambient temperature. The formula establishes a quantitative relationship between biological activity and environmental conditions. Cricket chirping rate increases linearly with rising temperature, reflecting metabolic activity. Dolbear's law provides a simple, nature-based method for temperature approximation. This law exemplifies the interconnectedness of biological and environmental factors. Male crickets chirp primarily to attract potential mates. The complexity and rhythm of cricket songs can indicate a male's fitness. Female crickets use song complexity to evaluate potential mates. Chirping serves as an acoustic signal for mate selection in crickets. Song characteristics are crucial for reproductive success in crickets. Female crickets evaluate potential mates based on the information encoded within the male's chirp. The characteristics of a male cricket's chirp provide cues about his genetic quality and overall fitness. These acoustic signals directly influence the female's mate selection process and subsequent reproductive success. By selecting mates with favorable chirp characteristics, female crickets enhance the survival prospects of their offspring. Crickets utilize chirps to establish and defend their territories. These territorial calls serve as a warning signal to potential rivals. Chirping helps crickets maintain dominance within a specific area. Territorial defense through chirping ensures resource control and mating opportunities. The intensity and frequency of chirps correlate with the strength of territorial claims. Aggressive chirps are characterized by their loudness and forceful delivery. These chirps signal a willingness to engage in conflict over resources. Aggressive chirping can also indicate a defense of territory. The purpose of aggressive chirping is to assert dominance and ward off rivals. Aggressive chirps differ from courtship calls, which are typically softer and more melodic. The intensity of aggressive chirping is proportional to the perceived threat or value of the resource. Crickets often chirp simultaneously, creating a chorus effect. The collective sound of a cricket chorus amplifies their presence in the environment. A cricket chorus increases the communication range for individual crickets. The cricket chorus serves as a form of collective communication. Certain cricket species synchronize their chirps, creating collective rhythmic patterns. Chirp synchronization enhances the ability of crickets to attract mates. Synchronized chirping can also deter predators through collective acoustic signaling. The rhythmic patterns formed by synchronized chirps amplify the signal's effectiveness. Human perception of cricket sounds varies significantly. Cultural context influences the perception of cricket sounds as either soothing or irritating. Personal preference plays a key role in whether cricket sounds are perceived positively or negatively. Individual experiences shape the subjective interpretation of environmental sounds. In certain cultures, crickets symbolize good luck. Crickets are also associated with prosperity in some societies. The chirping sounds of crickets evoke positive emotions. Cricket sounds are often linked to feelings of nostalgia. Cultural beliefs often attribute symbolic meanings to natural elements. These cultural associations enhance the perceived value of crickets. Cricket farming is an emerging industry focused on raising crickets for food and animal feed. Crickets are a sustainable resource due to their efficient protein conversion. Cricket farming provides a novel solution to global food security challenges. The nutritional value of crickets makes them a viable alternative protein source. Ecological dynamics and environmental changes can be understood through the study of cricket sounds. Bioacoustic studies of cricket sounds provide valuable ecological insights. Analyzing cricket sounds reveals patterns indicative of environmental health. Variations in cricket sound characteristics correlate with specific environmental stressors. Long-term monitoring of cricket sounds can track environmental changes over time. Bioacoustic monitoring uses cricket sounds to evaluate habitat health and biodiversity. Analyzing cricket sounds provides early warnings of environmental degradation. Monitoring cricket populations through sound is a non-invasive method for assessing ecosystem status. Changes in cricket sound characteristics can indicate shifts in environmental conditions. In urban environments, cricket sounds can contribute to noise pollution. Noise pollution from crickets can negatively impact human well-being. Understanding the impact of cricket noise is crucial for effective urban planning. Urban planning strategies can mitigate the negative effects of cricket-induced noise. Effective urban design considers the acoustic environment to improve quality of life. Human-generated noise can mask cricket sounds, disrupting their communication. The masking of cricket sounds by human noise can negatively impact their reproductive success. Effective communication is vital for crickets to attract mates and reproduce. Increased noise levels reduce the range over which crickets can effectively communicate. Sound masking disrupts the natural auditory environment, crucial for cricket survival. Conservation efforts are crucial for preserving cricket habitats. Maintaining cricket populations is essential for ecological balance. Cricket habitats support biodiversity and ecosystem health. Habitat loss poses a significant threat to cricket populations. Conservation strategies include habitat restoration and protection. Protecting natural habitats is crucial for the survival of cricket populations. Reducing pesticide use supports cricket survival and the continuation of their characteristic sounds. Habitat preservation ensures the continuation of the cricket's role in the ecosystem. The characteristic sounds of crickets are indicators of a healthy ecosystem. Crickets contribute to the natural soundscape. Cricket sounds are an integral part of the environment. The sounds of crickets reflect the health of ecosystems. Cricket sounds reflect the diversity of ecosystems. Cricket's chirping creates a natural symphony. The absence of cricket sounds indicates environmental imbalance.